Matrices are an important part of R, especially because R is a statistical programming language and matrices are critical in a lot of statistics. It's widely used in a number of statistical methods such as principal component analysis, factor analysis, and SEM. So what is a matrix? A matrix is a two-dimensional construct of the same type. And the reason this is important is because R has some special functions and operations specifically designed for matrices, such as matrix multiplication. Here we have an example to the right of a matrix that has 3 rows and 2 columns. So you'll notice it has 1 and 4 in the first row, 3 and 7 in the second row, 8 and 1 in the third row. When we define and reference a matrix, we will do so by rows first and then columns. Creating a matrix is simply done by using the matrix function. We pass it a vector of values, followed by the number of columns, the number of rows, and then another indicator which will state whether or not the data is being put in by row or by column, so that we can order them properly. To create the matrix on the right, the following code is used. We have matrix, followed by the vector 1, 4, 3, 7, 8, 1. Number of columns is 2, number of rows is 3, and we're going to put the information by row, which means the 1 and 4 will go in row, then the 3 and 7, then the 8 and 1. If we change the by row to false, it would put the 1, 4, 3 in the first column and the 7, 8, 1 in the second column. So by specifying the n column and n row attributes, it determines the matrix dimensions, and the by row parameter will determine how the values of the vector are placed in the matrix. Here we have 3 other matrix examples. We have the A matrix, which is a 2 by 2 matrix, and you can see that it puts in the vector 2, 1, 3, 2 by row equals false. So in other words, it will put them in by column. In the second case, we have B equals a vector of 1 through 6, n column equals 3, by row equals true, so it will put the information in by row. And you can see that we've left off the number of rows because if we have the number of columns, it'll automatically know the number of rows that it will need. And finally we have the third matrix, C, which has a vector of 1, 0, 0, 0, 1, 0, 0, 0, 1. Number of columns is 3, by row is true, so it will put the information. And for those of you who are familiar with linear algebra, this is an identity matrix. We'll do more of those in a future module. Now, what makes matrices special are the operations that can be performed. So one of the key ones is matrix multiplication. Matrices can be multiplied using the %% operator. Now, matrix multiplication is definitely different than just multiplying each cell by a cell from a corresponding matrix. You'll discuss more of that in the linear algebra section. But if you're familiar with matrix multiplication, this is how it's done. We'll create our first matrix A and our second matrix B. The first matrix has a vector of 2, 3, 2, 2, which is a 2 by 2 matrix, and the second matrix has a 5, 1, 3 vector, also in a 2 by 2 matrix. We will then create a new one called C, in which we multiply the A matrix and the B matrix using the %* operator. Other specific functions on matrices include the eigenvalues and the determinants, which are done with these 2 functions below. Finally, if we're going to access elements, and we access them in a similar way we did with vectors. Here we have a matrix M, which has a vector of 1, 4, 3, 7, 8, 1, in a 3-column by 2-row matrix. We will use the brackets again to reference the individual elements. So we have M11, which will be the first row, first column, which would be a 1. We'll also have M23, which would be the second row and third column, which would give us a 5. Finally, if we do M1 by itself, it's going to print the entire first row. Now, what we can do is we can actually replace a particular element, again, by doing a reference, and we could do M2 comma 1 as an alternate, which will be the row 2 and the first column, and that will replace that with a 21. So it replaces the 7 in row 2, column 1 with a 21. We could also have done this as M bracket 2, bracket 1, and we'd get the same result. We could apply the 21 into bracket 2, bracket 1. In some of the other classes, you'll be dealing with a lot of matrix operations, so these will become fairly second nature.